similar shapes have to have the exact same ratio?
Right. They have to have the same exact ratio. What does that mean? In order to do this, we're going to do something. Let's find all the congruent sides. Let's find all the sides that match up. Okay? Oops, sorry. Here we go.
Oops.
Yeah,
Mr. D, Alyssa's here.
that's good. Can we kick one of these triangles out?
Yes,
Why?
because the smallest one isn't for the first two, for one that says A, B, C, that is 2 times the two of those triangles can fit in the biggest one.
So we're going to talk about that. Normally, you'll only have 2 shapes that you need to sort through. So we're going to kick this one out because we know that that one doesn't belong. And now we're going to prove it. For these 2 shapes, let's find the corresponding sides. Which sides are corresponding? Match up. Can we agree that AB corresponds to XY?
No.
No.
No, because they're not the same length.
Not congruent, corresponds.
Okay.
They're in the same
Yes.
location.
Yes.
So I'm going to write line segment AB and XY. But they're not congruent. So I can't use that little similar shape. What I can do is use that shape. Do you remember that shape?
About.
In geometry, that symbol means similar. Now, let's keep going around. BC and YZ, BC and YZ. BC is similar to YZ, and CA is similar to ZX. Now let's compare them. Mathematically, we're going to compare those. How long is AB?
6. 6 squares.
How long is BC?
5.
How long is CA? 5. We're going to divide these by the size of the corresponding side. How long is XY?
12.
How long is YZ? How long is ZX?
15.62.
Whoops, I did that wrong. 6, 2. 6, 2. Now it's time for Mr. Calculator.
Mr. Calculator.
What is 6 divided by 12? No, Nick M. Put up 6 fingers. Divide them by 12. Ah. So what is 6 divided by 12? No, not 0. Another way to write this would be this: 6 divided by 12. What's 6 divided by 12?
I know it. I just used Mr. Calculator.
That's a fraction. And we're going to put that fraction into simplest form. What is 6/12 in simplest form?
You have two choices, Nick M. Nick says 0.5, which is not wrong, or you could use the fraction. Jay?
1/2.
You're not Jayla.
Oh.
Jayla? 1/2. Either is, yep, either is perfectly fine. So 6 divided by 12 is 0.5 or 1/2. What is 5 divided by 10? 2, right?
Mm-mm.
No. 5 divided by, what's 5/10?
0.5.
0.5 or
1/2.
1/2. 0.5, 1/2. What is 7.81 divided by 15.62? 0.5
Or 1/2.
or 1/2.
Well,
What do you notice about all of those answers?
they're all equal to 1/2.
Right, because this and this and this have the same ratio. Ratio is fractions that are the same. Because each of your corresponding sides is the same ratio, then these two shapes are similar. Stay with me. I'm going to go to a new page. Let's make another shape.
I like shapes.
Oops, you see? And again, I'm using colors. If you want to, you can. If you don't want to, you don't have to.
Oh.
What happened now?
Are these two shapes congruent?
No.
Are those two shapes congruent? Same exact shape, same exact size. Thumbs up, thumbs down. Perfect, good. No. Are they similar? Thumbs up, thumbs down. Let's match up the corresponding sides and see if they all have the same ratio. So here's what I'm going to do. Let's take this one, AD, line segment AD, and we'll compare that to WZ. And then DC will get compared to ZY. And then CB will get compared to YX. and BA compared to XW. Now, what's the measure of AD? AD is 4, right? What's the measure of WZ? WZ is 6. Use Mr. Calculator. What is 4 divided by 6? In math, we would do 4/6 or 2/3. Nick is giving me a high five. No? 0.6666666666666. Yep. So I'm going to put the ratio as 0.6 continued. That's a repeating decimal. That's the ratio between those two shapes. Now let's do DC and ZY. DC is 4. ZY is 4. Use Mr. Calculator. What is 4 divided by 4? Oh, Nick says, hold on 1 second. Okay. 1 minute.
Nick, just unmute yourself.
1 minute. No, he's just leave him alone.
Then it's 1.
Oh,
Number
okay.
1.
It's 1. Good. Now let's compare CB, which is 4, and YX, which is 6. What's 4 divided by 6? It's the same as over there, right? 0.6 continued. And BA is 4. Oops, I forgot my little symbol. 4. WXXW is 4. That's 1. So let's look at these comparisons, these ratios. We've got 0.6, 1, 0.6, and 1. Are all of those the same? Because they're not the same, these two shapes are not similar. Those two shapes are not similar. Is that making sense? The biggest thing that you have to get through your head is similar doesn't mean they look alike. If I asked you if these two shapes looked alike, would you say yes or no? Yeah, kind of. They're both quadrilaterals. They both have 4 sides, 4 angles. They look similar. But in the math world, mathematically speaking, they are not similar. They are not similar because their ratios of all their corresponding sides are not the same. Okay? So what we would do is we would use this symbol. Similar, not. Similar, not. Similar, not. Similar, not. It looks like a fancy X, but it's that tilde symbol with the lines, a diagonal line through it. Excellent. What time we got here? Oh, 10 more minutes. Perfect. How can we find, are these two shapes congruent? Same exact shape, same exact size. We know they're not congruent because we can see that those sides are different sizes. Yes? Excellent. So they're not congruent. How can we find out if those two shapes are similar? How can we find out if those two polygons, those two triangles are mathematically similar? Nick?
I just
Nick M?
you have to. I know what to do. I don't know how to word it. So you
Good, that's why I'm asking.
you have to you have to get. So you put A and B. So you put
Okay.
line A and B. Just go over the A and B.
A, B, which is right here.
And then you gotta, and then you can do X and Y.
Okay, what you're doing is you are comparing sides. That's what you're doing.
So you gotta compare the sides, yeah.
Compare sides. Yep. AB compared to X,
X.
Y. Right? Corresponding sides. Would you compare AB to XZ?
No,
Why not?
cause I don't know. I just no.
Can Nick compare AB to XZ? Is that okay? Reba?
No, because they're two different. You can't compare two different sides because they have different sizes. Different
Okay.
sides because they have different sizes.
Why not? Why? Why are they different? Why?
Why?
Because they're a different part of the triangle.
Yes, their sizes doesn't matter. The part of the triangle matters. That's what matters. This side is right above your right angle, and this side is right above your right angle. This side is opposite your right angle. Does that make sense? And this side is on the other side of the right angle. So when Nick was doing this, he did it right. AB can only be compared to XY. And BC can only be compared to what, Nick?
X, Y.
No,
No, Y, X. Sorry.
no,
What? Y, X.
no.
What?
BC can only be compared to
Y, X. Oh, that's a Z. Y, Z.
X would be this letter.
Okay.
Z would be this letter.
Like Superman.
Oh.
That's okay.
I knew it. I just
Did you
didn't.
write the wrong thing on your paper?
No.
Okay, that's fine. Right? And CA can only be compared to ZX. Now let's find the ratio for each of those. Right? Let's find out what we get when we divide. AB is 6. YX is 5. What is 6 divided by 5? Use Mr. Calculator and do 6 divided by 5.
1.2.
Abby?
1.2.
1.2. Now let's do BC. BC is 6 divided by YZ, which is 5. What is 6 divided by 5? 1.2. We already did it. CA is 8.49. divided by 7.07.
1.200
1.2.
846
So what do you notice about all these ratios?
They're similar.
No.
They're all the same.
Right. All ratios are the same, comma, same. So the shapes are similar. They're not congruent, but they're similar. In order for shapes to be similar, all of their sides need to have the same what?
Quotient.
No. In order for shapes to be similar,
They
all
have to
of
say
their sides need to have the same
length? No.
It rhymes with blatio.
Ratio.
Ratio. All of the sides need. Now, I have a question. And my question is keeping the same shapes. What were to happen if I compared, instead of doing AB to XY, if I had done XY and AB?
It would have been
And YZ to BC? And ZX to CA? How does that change things? Or does it change things?
it definitely changes things.
Okay.
Because if you do
Let me
6
hold on. Let me get Nick F. Nick F. What's the measure of XY?
5.
Yes. And what's the measure of AB?
6.
What is 5 divided by 6? Do you have a calculator, Nick?
Yeah.
Go ahead.
0.833333.
Yep. 0.83. And in math, we put this, continued. That means that 3 goes on forever. Now let's do YZ and BC. YZ is what, Nick?
5.
Yes. BC is what?
6.
What is 5 divided by 6?
0.83.
Continued. And let's do ZX. And CA. What do you get as your ratio?
0.83. 2.
Yeah.
I just get a bunch of numbers.
But the main thing is you got that, right?
Yeah,
Yep. What do you notice?
they're all the same.
but it's just different numbers.
Does it matter?
No.
No, because here what you're saying is this shape is similar to this shape, but it's bigger. On the blue one, we compared this shape to this shape, and this one is smaller. See how these numbers are greater than 1? That means the shape that we're starting with is bigger.
Yes.
These numbers are smaller. That means the shape that we're starting with is smaller.
Yep.
When you work on your independent practice tonight, you're going to be looking at, excuse me, congruent sides and similar figures. You're going to be finding if shapes are congruent or not. You're going to be looking at congruent sides, corresponding angles, corresponding sides. And you're going to look to see if shapes appear to be congruent. In one of the sections, they give you shapes with no numbers. So you can't find out mathematically. You're supposed to use your eyes and see if they look like they're congruent. And then you're going to do some corresponding angles in the last section. Okay? I think you're going to be fine. What I would like to do is do this tonight. It's due by 4:30. It'll be out in Google Classroom at 10:30. I would expect a quiz on Tuesday-ish of next week. I believe Tuesday or Wednesday. Does anyone have any questions, comments, issues, thoughts, concerns, lamentations, feelings, ponderings? Reva?
My math book's almost out. Can I just use spare pages because we're near
That's
the end?
fine. Yep. Excellent. All right, you're good to go.